Hello, Math 120, and this is Professor Gonzalez, and I'd like to do some problems from Homework 5.4. And 5.4 is all about rational equations. So that would be equations that have fractions that are made up of polynomials. Now, we've got basically the idea of this is that you have an equation with fractions, and our number one strategy is to knock out those fractions by multiplying the left and right side of the equation by the LCD. And that will always, when you multiply by the LCD, you're guaranteed to cancel common factors because the LCD is a polynomial that each of those denominators will go into, therefore will reduce with. And so therefore, so basically the idea is you clear the fractions, making a new equation without fractions. There is a caution here because the equation with fractions had the possibility of getting a zero in the denominator, which would be undefined. So this new equation could give us answers that are called extraneous, that actually don't work, even if your math is sound, because the new equation didn't have fractions, and so we lose the idea that you might have a zero in the denominator. Okay, so that has to be, we have to keep that in mind in our final answer. I'll show you how to do that. Okay, let's go for it. And, oh, just to let you know, also, if you remember way back when in the day, you could also think of this as a proportion and cross multiply and solve it that way as well. But that's only going to work with a fraction equals a fraction. And as you can see, we're going to be doing problems where there's a fraction plus or minus, a fraction equals a fraction, and so you cross multiplying is not going to happen there. So we're going to give you a technique that works for all situations. But I thought I should just for transparency let you know that that old way of cross multiplying does work when you have a fraction equals a fraction. Okay, so let's take a look and see how to do this. And this is step by step. Determine the domain of the variables in the rational equation. Okay, so basically this is what I'm talking about. We are going to highlight this little guy right here and ask, what can you put in for x that would make it undefined? In other words, x plus 2, when that equals 0 in the denominator, that is a big problem. So subtract 2 on both sides. That means whenever x equals a negative 2, we have an undefined situation there. Now the other one, x equals 6, in this particular example, they already did that for us, right? When x equals negative 6, this results in division by 0 right there, so that is not allowed. So they already put that down. X cannot equal negative 6 causes the problem, but so does x equal negative 2. So then if we're going to talk about a domain, we'd say, the way we say it is the set of all x's such that x cannot equal what? Negative 2. And then they already have the other one, x cannot equal negative 6. Okay, next step, determine the least common denominator. So when we look at these two denominators, or these two factors, I should just call it, right? These are factored. So my LCD has to have both of those unique factors in it. So LCD must have x plus 2 times the quantity x plus 6. It's going to have both of those. Okay, now multiply it. Here we are at step number 3. Multiply both sides of the equation by the LCD and simplify the expression on each side. So remember my LCD, and let me just use, I think I'm going to use yellow for the LCD now, okay? So the LCD is this yellow stuff. So what we did was we multiplied the left side by the LCD and the right side by the LCD, okay? The question is, when you reduce, what are you left with? Well, you can see, I'm going to use some color here. You can see that we have a factor of x. Let me zoom in here. We have a factor of x plus 2 and an x plus 2. So those factors will reduce, leaving us with the remaining x plus 6 times 4, and that shows up right there. Okay, on the right-hand side, you can also see that we have a factor of x plus 6 and x plus 6, so these reduce, leaving a factor of x plus 2 times 1, and that's what happened on the right-hand side. Next step, then it says multiply. Okay, well, we can, of course, distribute, giving us 4x plus 24. Of course, multiplying by 1 just gives itself identity. Okay, and then they would like us to subtract x on both sides. So we subtract x on the right, subtract x on the left, which gives us 3x. Then they say, how about if I solve for x by subtracting 24 on both sides? 24 on both sides gives us 3x equals negative 22. Then the last step is to divide both sides by 3. And we've got kind of a weird, nasty negative 22/3 of an answer. Okay? Okay, now it says, step 5, check your solution. Now, I told you before that checking your solution is optional. It's just if you have time on the test, you check it. With this particular problem, you have to either check your solution or you have to look for extraneous solutions by looking at this list up here, what x is not allowed to be. Okay, you kind of can do it either way, but you have to do one of the two because there are some undefined some values that we cannot use in our domain. But anyhow, this is a way of checking the solution. How do you check a solution? Well, you just take your answer. You just take your answer and stick it in for x, right? So that just goes here and here. And then you just simplify after that. So the answer was negative 22/3, negative 22/3. Of course, you do the math, and it turns out that negative 3/4 equals negative 3/4. So that is true. And so therefore we can say, therefore, that number that we used, negative 22/3, is the answer. Okay, number 2. So let's see if we can do this procedure again. And here we go. Let me write this down so I have some space to operate. And that would be 4 over z rather, minus 1 over 4z equals negative 3/20. So the very first thing we need to do is we need to find our LCD. Let me do that right here, LCD. Well, the LCD, it could be a z of 4z or 20. So our LCD is going to be what? 20z. So we multiply both sides by 20z. Now every term on the left, so I'm going to put parentheses around this, right? And so it needs to be distributed. So let's just go ahead and realize that we're going to have to distribute to every term. So this is going to be 4 times, and this will be 20z. And then the next term is 20z up top and 20z up top. Now, I just want to let you know that very often what happens with this negative symbol is it gets lost. In this case, it's probably not going to get lost too easily, but in many cases it will. And the trick is just to write that as plus a negative up top so you don't lose it. Okay, let's go ahead and do some reducing here. And we can see that, let me use another color now since I just blew through the green. Let's use blue. You can see that as a factor of z's will reduce, leaving us with 4 times 20, which is 80. You can see that there's a common factor of 4. 4 goes into 4 once, 4 goes into 20 5 times. Z goes into z once, z goes into z once. And we're left with a negative 5, aren't we? And continuing on the right-hand side of the problem, we have common 20, so 20 goes into 20 once, 20 goes into 20 once, leaving us with negative 3 times z, which is negative 3z. Okay, now what? Now we want to combine like terms. Go back to black here. I've got 80 minus 5, which is 75, equals negative 3z. I divide both sides by negative 3. and I get z equals negative 25. Now before I call that my answer, I do have to make sure I check restrictions in the domain. What is going to cause, so what can z never ever equal? Well, if you divide by 0, that's going to be a restriction in the domain. That's something z cannot be. And you can see there's a z in the denominator, so z cannot equal 0, right? Because if z was 0, you'd be dividing by 0. Turns out that my answer is negative 25, so that is a great valid answer. Let's go on to the next problem. Whoops, what just happened? That just moved on me. Let's go to the next problem. The next problem says to solve the following equation. Be sure to verify your results. So once again, they did say to verify it, so you probably should check it. But what I'm saying is what we did was we didn't really check our math. You still could have a math error here, but really the difference with this procedure is that you actually can do all your math correctly, but because we changed this problem with fractions in it, that clearly if z was 0 it would be undefined. You lose that when you clear your fractions, you lose that. And now you have this linear equation that, notice z is right here, and technically z can be 0, right? And so you lose that fact when you clear the fractions, and that's why you really need to state that this blue equation that I found is easier to work with, but it does have to have a little asterisk next to it saying that it gives me the same answers as the original rational equation, except for z equals 0. That's the one guy right there that cannot be included in the blue equation because it does not work for my original equation, okay? And you lose that fact, or you lose the sight of that when you clear your fractions. So it is important to put that in there, and that does help us check for extraneous, make sure that's not an extraneous solution. Let's take a look at the next one. And like I said, technically you could cross multiply and do it that old way that we saw from probably junior high even. But we're going to just continue with this idea of clearing the fractions by multiplying by the LCD because it does work on all situations. So you can see, let me rewrite this so I have a little more space to operate. And this is going to be, let's write this as y plus 3 over y minus 8 equals y plus 9 over y plus 1. All right, so we find out our LCD. You could also look at your restrictions at this point too. It wouldn't be a bad idea to do that. Let's write the LCD. LCD is what? Y minus 8 times y plus 1. That's your LCD. Let's do our restriction. I'll go ahead and do that in blue, I guess. No, I'll do that in red. Seems like red is a good cautionary kind of thing. So the restriction is going to be what makes this equal 0, because that's what we can't have, right? So you add 8 on both sides, and y, we're having a little lag with this thing, y cannot equal positive 8. That's the first problem. And over here, when this whole thing, y plus 1 equals 0, we got a problem, right? That's going to be undefined. So subtract 1 on both sides. Y cannot equal negative 1 because that's going to make an undefined situation. Let's go ahead and get that out of the way now. Let's just put this over here. These are our restrictions. Okay, and we continue with the problem. So we got to go back to this. Whoops, that's not what I wanted. We got to go back to this in the end to check our solution. Okay, let's multiply by the LCD, and the LCD is y plus 1 times y minus 8. And y minus 8 times y plus 1. Let's go ahead and reduce common factors like y minus 8 and y minus 8. And now we're going to have to multiply. Y times y is y squared. So this gives us, whoops, I've gone way too far here. This gives us y times 1. So this gives us 1y plus 3y gives us 4y in the middle. We're just adding it together in our head. And 3 times 1 is 3. moving right along to the right-hand side of the equation, I'm going to reduce common factors. How about y plus 1 and y plus 1 reduce, which then gives us, let's see, y times y is y squared. Now we've got negative 8y, positive 9, which gives us positive 1y. And 9 times 8, well, that's going to give us what? 9 times 8, it gives us negative 72. Okay, now all we have to do is solve for y. We need to set it equal to 0. So we're going to subtract y squared on both sides. Of course, that just zeroes out, giving us 4y plus 3 equals y minus 72. How about if we do this in one step? How about if we subtract y on the left and right and add 72, because we want to set this equal. No, we don't. I'm sorry about that. Take that back since this is not a quadratic anymore. Let's just continue with our path here. So we're trying to get y on the left-hand side, so this gives us what? 3y plus 3 equals negative 72. We subtract 3 on both sides, gives us 3y equals negative 75. Divide by 3, and y equals negative, same answer as last one, negative 25. That's weird. And now we have to check our restrictions. I'm going to rewrite my restrictions just to highlight that. Y equals negative 25 as long as we check our restrictions. Restrictions say y cannot equal 8, y cannot equal negative 1. Well, that's not what I got, so this is just fine. Let's look at the next problem here. Next problem is number 4. We're going to go about it. It's a very similar way. We're going to look for the LCD. Whoops, what's going on here? Stop. There we go. We're looking for the LCD. This won't let me write on it until I clear it. Clear it. Come on. There we go. We're going to look for the LCD, and the LCD is going to be x plus 7 times x minus 1. Let me write this whole thing again so I have some space to operate as usual. This is going to be x plus 9 over x plus 7. That equals x plus 1 over x minus 1. I can see that my LCD is x minus 1 times x plus 7 and x plus 7 times x minus 1. The order of that multiplication doesn't matter. The only reason why I switch it like that, and it's not a big deal, it's just because it just lines, it makes it so I cancel the one that's furthest away, so it's easier to see this distribution. That's the only reason why I do it that way, but it doesn't make a difference. Now, we reduced common factors of x plus 7, so now we're left with multiplying that out. That gives us x squared, and of course this is x times negative 1, so we got negative 1 plus 9 gives me 8x in the middle, and 9 times negative 1 is negative 9. If that was confusing, then you should just take some time and do this whole process over here, and you'll find that it ends up becoming what I just got. Okay, on the right-hand side, let's take a look at that, and I can see a common factor of x minus 1, which reduces, leaving me with this multiplication problem, right? So I got x squared. Now I got 7x plus 1x gives me 8x in the middle. And I've got 1 times 7 is 7. Okay, so the very first step, you can see if I'm trying to get it in a standard form, it turns out that those x squares just zero out. So now I've got 8x minus 9, and I'm really running out of space here. So let's see. Well, that's okay. It looks like something weird's going to happen here, huh? I subtract 8x on both sides, and my variable drops out. 0, 0. Right, my variable drops out, leaving me with the statement negative 9 equals 7. Now, is that true or false? That is false. That's a false statement. So when our variables drop out and we have a false statement, the answer is going to be no solution. Okay, no solution. Let's take a look at number 5. Number 5. Okay, now we're getting a little more complicated with 3 rational expressions. One rational equation, but 3 rational expressions. So I'm going to write them right here. This is 3/2, right, plus 2 over x minus 3. And having a lot of space in between is really nice because we're multiplying by these polynomials, which get a little bit bulky and squished in there if you leave it like this up here, right? So the very first thing I always like to do is take a look at my LCD. LCD, okay, we've got a 2, we've got an x minus 3, and I think we better factor this so we can really see what the LCD is. Factor out a 2 and this is x minus 3. Hey, how convenient. The LCD is 2 times x minus 3. You'll notice that they kind of do that a lot in this book where, the LCD, otherwise if each one of these denominators was unique and different, your LCD gets really big and out of control, makes the problem real hard. So usually they're not too bad. But now we have the LCD, so we're going to multiply both sides by the LCD. Now, if you find that you're forgetting to write down the restrictions because you're blasting through these fractions, or you're getting rid of the fractions and then forgetting about the restrictions, well, if you are doing that, then you better do your restrictions right now, and that's probably a good idea. Meaning, what can x not equal? And all I'm seeing right is this guy right here, right? Because x minus 3 and x minus 3, that's where the variable is, and that's what's going to cause a problem. Meaning, if x equals what? If x equals, let me just write over here. If x equals, you can see if x equals a positive 3, then we would have a positive 3 minus 3, which would make a 0, which we cannot divide by 0. So that's your only restriction. Let me get rid of some of that stuff. That's your only restriction. Okay, so we've got to remember that in the end, at the very end when we're finishing our problem and checking for restrictions. Let's multiply both sides by the LCD, and that is going to be 2 times x minus 3 and 2 times x minus 3 and 2 times x minus 3. So let's go ahead and do some reducing here. You can see a common 2 reduces, leaving us with, let's go ahead and distribute 3x minus 9. And you can see x minus 3 and x minus 3 reduced, leaving us with this beautiful 4. And then a whole bunch reducing happens, leaving us with just this numerator of x plus 29. So this one looked maybe like it was going to be a tougher problem, but I think it's kind of cleaning up nicely in some ways. We have a 3x and a negative 9 plus 4 is going to be minus 5. We have x plus 29. This is linear, so we're just going to go ahead and get all our x's on the same side, right? Which just gives us 2x minus 5 equals 29. You add 5 on both sides mentally or whatever, write it down, and we get 2x equals, what's that, 34, divide by 2, and x equals 17. And now we have to check. You have to check your restrictions. And 17, but x cannot equal x cannot equal 3. Oh, I didn't get 3. So 17 is a fine solution. Okay, x equals 17. Moving on to the next problem. Boy, look at that one. Okay, so now we're starting to get into tougher problems. We have to factor. We have to, we've got 3 rational expressions. And like I said, some factoring involved. Not to scare us off, we can do this. So we write down the problem as, 5 over x minus 1. We give myself some space to operate, 6 over x minus 6. And this whole thing equals this, x plus 64 over x squared minus 7x plus 6. Okay, so before we find an LCD or restrictions, we need to factor completely. And basically, we're looking for what 2 numbers multiply to 6 and add to negative 7. That's going to be x minus 6 times x minus 1 multiplies to positive 6 and adds to negative 7. So this is now factored. And wow, how about that? Those are the same factors we have over here. How convenient. That makes that LCD nice and easy to get. LCD is x minus 6 times the quantity x minus 1. We're going to multiply both sides by that LCD, x minus 6 times x minus 1, x minus 1, whoops, times x minus 6, and x minus 6 times x minus 1. And the great part is reducing. Oh, well, before we reduce, maybe we better make sure that we can say x better not ever equal what? X better not ever equal positive 6, because that makes a 0 in the denominator, and x better not ever equal positive 1, because that makes a 0 in the denominator. Okay, now let's move on. Make sure we talk about this in the end. Now we move on. Reduce common factors. Well, I see a factor of x minus 1 and x minus 1. That was fun. Distribute the 5x minus 30. Now go ahead and reduce common factors again, x minus 6 and x minus 6. Distribute, equally as fun, 6x minus 6. And over on the right-hand side, we have common factors of x minus 6, x minus 6, x minus 1, x minus 1, leaving us with this numerator. This is not going to be too bad after all, I don't think. Now let's combine like terms. So I've got, 5x and 6x, which is 11x. And I have a negative 30, minus 6, which is minus 36. There we go. Let's go ahead and solve for x by subtracting x on both sides. This, of course, is going to give us 10x minus 36 equals 64. Let's add 36 to both sides. This gives us 10x equals, 36. This gives us 100, right? Yeah, it gives 100. Divide by 10, and that's an easy problem. X equals 10. Now what we need to do is we need to look at our restrictions. I'm going to write it right next to it. Guess what? X better not equal 6. X better not equal 1. And it doesn't, so we're good. X equals 10 is the answer. Let's move on to number 7 and see how that goes. I see a potential problem right off the bat, and that usually is this little guy right here. Whoop. Come on. There we go. This little guy right here can get lost, so I tend to like to write it up there so it doesn't get lost in the procedure. Let's see what happens. Okay, let's go ahead and write this down. This problem is going to say, well, we got 3 over x plus 6 equals 6x over x squared minus 36 plus negative 16 over x minus 6. Now, before we can do this, right, we need to factor completely to find our LCD. And it turns out that this is a difference of two squares, so x plus 6, x minus 6. Ah, surprise, surprise, it's the same two factors of the other fractions or rational expressions. So we go up here and we look for our LCD. LCD is going to be x plus 6 times x minus 6. Let's clear these fractions by multiplying by the LCD, but before that, let's go ahead and write down our restrictions. X better not ever equal what there? Let's focus on, there's just two factors, right? Well, I just want to make sure you guys know that, I'm sure you see that x plus 6 is the same as, oh no, I just did that. You can see that x plus 6 is the same as x plus 6, x minus 6, x minus 6. So you don't have to look at every denominator because there's duplicates right there. Right. So when we look at these two, you can see that what's going to make a 0, well, you can see when x equals negative 6. When x equals negative 6, negative 6 plus 6 is 0. So that's not a possible value of x because it causes an undefined. And you can see when x is what, 6? 6 minus 6 is 0, so x is 6 is also not in our domain, can't use it. Okay, so At this point, we can move on. Let's multiply both sides by our LCD. Our LCD happened to be x minus 6 times x plus 6, and x minus 6 times x plus 6, and x plus 6, x minus 6. Okay, reduce common factors of x plus 6 and x plus 6 and distribute 3 times x is 3x and 3 times negative 6 is negative 18 equals. Let's reduce common factors, right? X minus 6, x minus 6, x plus 6, x plus 6. That just leaves us with a 6x. And one more color to operate with. How about, no, red's not going to work. We already have red. How about this gold orangey color? X minus 6, x minus 6. Distribute your negative 16. You see how that negative sometimes could get lost if it's left there? And that would be really bad, because you probably just put the negative on the first term and not distribute to the second term. But when it's right there, usually we've got a better chance to realize that negative 16 times x is negative 16x, and negative 16 times 6, well, that gives us a negative, what is that, 6, what's that, 60 and 36, 96, negative 96. Okay, so it gives us a much better chance that we distribute the negative and not forget it. Now what we're going to do is we're going to combine like terms and simplify and all that stuff. So of course when we simplify that, that gives us a negative 10x minus 96. We got 3x minus 18. Okay, why don't we go ahead and add 10x to both sides? Adding 10x gives us 13x minus 18 equals negative 96. We're going to add 18 to both sides, which gives us 13x equals, let's see, negative 96 plus 18 is negative 78. Dog's going crazy because there is a FedEx guy out there. Okay, so now divide both sides. The dog's nemesis is FedEx guy and UPS guy and Amazon person, you know, so dog has lots of things to guard, these dangerous delivery people, and the mail person every once in a while. Okay, divide by 13, and x equals a negative 6. Now, we did all our math correct. We didn't have any errors. And if you call that the answer, you're going to be wrong. What? How can that be? Well, because remember when we were at the beginning of the problem and we said we don't like fractions, we're going to clear them. Well, you got a new problem, which is this guy right here. You got a new equation, I should say. And this new equation is pretty dang good, but it's not perfect. That new equation will give me answers for the old equation, right? It'll give me answers for the old equation, except, whoops, it might give me an answer that doesn't belong, that can't be. And what are those restrictions? Oh yeah, these are the restrictions. Okay, I can use this new equation just as long as I remember that x cannot equal negative 6 or 6. And whoops, but look I got x equals negative 6, but x can't equal negative 6. Also can't equal positive 6. This gets scratched off the list. And so we have no solution. All that work, we felt like we got a solution, but there's no solution. And you know, you don't exactly have to know the name of this, but this is called, when you get a solution and it doesn't work, it's called an extraneous. It's called an extraneous solution. Right? It doesn't work. So when you have extraneous solution, you end up ultimately having no solution. All right, moving on to number 8. Number 8. Whew, look at that guy. Okay, well, we're going to have 2x plus 7 over x minus 7 plus, I got x plus 14 over x minus 12 equals x plus 14 over x minus 7. All right, now, first things first, I think. Well, the first thing should either be LCD or restrictions, those two. But I'm going LCD, but don't forget your restrictions. LCD, well, it's all factored, so we're good there, right? X minus 7, factor x minus 12, x minus 7, so LCD is x minus 7 times x minus 12 is our LCD. And let's put our little restrictions down here at this point. X cannot equal, and you can see it right there, I think. X cannot equal 12, because 12 minus 12 makes a 0. X cannot equal 7, because 7 minus 7 makes a 0. So there are my restrictions. Let me get rid of that, and that, and that. And let's go for it now. Let's multiply both sides by the LCD. And that would be, the LCD is x minus 12 times x minus 7. And the LCD is x minus 7 times x minus 12. And x minus 12 times x minus 7. And that first step sure looks like a mess. Kind of is. But some nice things better happen. X minus 7 will reduce. Now we want to go ahead and distribute this. If you want to go ahead and take an extra sheet of paper to show your work, that's fine. This level of math is really where you can start doing some of these steps in your head. If you find that you don't get it right, then write it down. Show more work. But we got 2x times x is 2x squared. And then we've got 2x times negative 12 is negative 24, and negative 24 and 7. And so this is where it can start getting, to the point where if you feel like you're going to lose something, well, then you should write it down, right? So then write it down. So let's write it down, right? So we had negative 24x and 7, which is negative 17x. But if you feel like that's going to cause a problem, well, then take some time and write it down. That's going to be 2x times x is 2x squared. Then I go this way. 2x times negative 12 is negative 24x. The middle term is 7 times x, which is 7x. And 7 times negative 12 gives us a negative 84. And so, if this step you could do in your head, then you could have saved some time. But if not, then do it right now. What's a negative 24x plus 7x? And that's negative 17x minus 84. So we've got x squared minus 17x minus 84. Let's do the next one. Next one, and we have common factors of x. Whoops, that didn't work. We have common factors of x minus 12 and x minus 12. So we must distribute. So x times x is x squared. And this gives us negative 7 plus 14 is positive 7x in the middle. And 14 times negative 7 gives us negative 98. Okay, how about the right-hand side? We have a common x minus, darn it, this thing. We have a common x minus 7 and x minus 7. And now we need to multiply. This gives us x squared. Now we have negative 12 and 14 gives us 2x. And 14 times negative 12 is negative 168. Now we just need to simplify and solve for x. So combine like terms, right? 2x and 1x makes 3x squared. So 2x squared, 1x squared is 3x squared. Then I go ahead, let me highlight some stuff. How about a negative? That's kind of a nasty combination, this green and this kind of yellow. Anyways, negative 17x, positive 17x. Add those together, we get negative 10x. And we've got a negative 84 and a negative 98. Negative 84 and negative 98 gives us negative 182. On the right-hand side, we have x squared plus 2x minus 168. Okay. How much space do I have? Oh, lots of space. Okay, so we're going to subtract x squared on both sides. 2x squared minus 10x minus 182 equals 2x minus 168. Now, instead of just writing many steps, I think at this step I'm tired of writing this over and over again. So I'm going to do this in one step. And you see me, I'll show my work. Subtract 2x, so we can zero that out. Subtract 2x on both sides. And then also add 168 so we zero out the right-hand side. So when we do this, we should get 2x squared minus 12x, 2x squared minus 12x. Add those together and we get a negative 14, and we get this beautiful 0 on the right-hand side. Now we've got to factor that, and you can factor that as a harder factoring problem, but you could also save some time realizing that there's a common factor of 2, which makes it an easier factoring problem. Now it's an easier factoring problem. We say what two numbers multiply to negative 7 and add to negative 6. And once again, it's easier factoring problem because the leading coefficient is 1. And of course, it's going to be a negative 7 times a positive 1 is negative 7, and negative 7 plus 1 is negative 6. Yeah, so that worked out. So this will factor down to x minus 7 times x plus 1 equals 0. Therefore, we set x minus 7 equal to 0 to get an answer. X equals 7. We set x plus 1 equal to 0, so therefore we get x equals negative 1. And do not forget your restrictions. What are those restrictions? I'm going to write them right down here. One of them was x can't equal 12. The other one was x can't equal 7. Wait a minute. X can't equal 7. You have to cross that, what's it called again? Extraneous solution. Have to cross that extraneous solution off the list because of the restriction x cannot equal 7. And so therefore we just get one answer of x equals negative 1. It's a great example that you will be punished, right, if you don't check those restrictions in the end. Once again, what did that mean? What that means is 7. We got 7 for an answer and negative 1. 7 and negative 1, those two answers work perfectly for what? Work perfectly for this. What color am I going to do? Works perfectly for this equation that I got after I cleared the fractions. Let me say that again. X equals 7, so 7 and negative 1 both work perfectly for this equation. But the problem is I was asked to solve a different color. I was asked to solve this equation. And so because that equation has these restrictions, x cannot equal 7 because a 7 would cause a 0 in the denominator, right? We have to get rid of the extraneous solution, and we just get one solution right here. X equals negative 1. Okay, number 9. Is this the last problem? No, I got 9 and 10, I think. Darn, I'm ready for a little break. My stomach is getting very hungry. Anyways, let's look at number 9. 9 says solve the equation, of course. So I'm going to have some space as usual. 3y plus 2 over y minus 2 plus 3 equals y plus 4 over y plus 2. Wow, some serious lag here. There we go, y plus 2. Okay, now that 3 is a whole number, and if you want to put a 1 so you know that that's the denominator, you can already see the factors in the denominator, so you can see quickly that our LCD is y minus 2 times y plus 2. And so the wife calling, yikes, I can't stop because I can't stop this thing, otherwise I have to edit it. Just make sure it's not an emergency. Costco, that's not an emergency, is it? Let's see, groceries, that's not an emergency. Needed work. Okay, going to work. Yeah, I think I'm good. Okay, so they're going to keep on going. Is that ignoring the wife? Nah. I checked, made sure she wasn't on the side of the road. Everything's good, which is grocery emergency. I got to finish this lecture. Then we'll take care of business. Probably be too late over there. But anyway, so let's take a look at this. So we have an LCD. Yes, good. So we multiply both sides by the LCD, and that's going to be y plus 2 times y minus 2, y plus 2 times y minus 2, and y minus 2 times y plus 2. So we're doing that. And before we forget, what do we not want to forget? Restriction. Y cannot equal, well, what makes that whole denominator 0? A negative 2 would do it, right? Negative 2 plus 2. And what makes that denominator 0? Oh, a positive 2 would be real trouble. So we go ahead and use those two restrictions. Now we're going to go ahead and reduce common factors of x minus 2, and we need to distribute. It's going to give us 3x squared. Nope, that's not even an x, is it? Better fix that. That would be 3y squared. So we get 3y squared. The middle term is going to be 3 times 2 is 6. 6 plus 2 is 8y. And then we get our final 2 times 2 is 4. Do the next one. I guess I'll use blue, but there isn't any reducing to do. How about if we realize that this is a difference of 2 squares? And so when we multiply them, we get the difference of 2 squares of y squared minus 4. And that gets multiplied by what? 3. So why don't we just distribute that out, which gives us plus 3y squared minus 12. Now on the right-hand side, we have the x plus 2 and x plus 2, which reduces. Now we multiply y times y is y squared. We get a negative 2 plus 4 is 2y. And 4 times negative 2 is negative 8. And so we've got y squared plus 2y minus 8. So we've got 3y and 3y is 6y squared. We got 8y. And we also have a 4 and negative 12. 4 and negative 12 makes a negative 8. And on the right-hand side, we still have this y squared plus 2y minus 8. Let's combine. Let's get everything to the left side so we set it equal to 0. And we're going to try to do this all in one swoop here. Let's see. Let's go with green. I'm going to subtract y squared on the right and subtract a y squared on the left. Then I'm going to subtract 2y on the right, subtract 2y on the left. And finally, I'm going to add 8 on the right and add 8 on the left. And so that's going to, of course, give me 0 on the right. 6 minus 1 is 5y squared. 8 minus 2 is plus 6y. And a negative 8, positive 8 is 0. And so now I factor out a common factor of y, leaving me with 5y plus 6 equals 0. Set each factor equal to 0. Set this factor 5y plus 6 equal to 0. So 5y equals negative 6. Divide by 5. Oops. And y equals negative 6/5. So here's my two possible answers, but I better check my restrictions. And my restrictions don't look very restricting because restrictions are just y cannot equal a negative 2, y cannot equal positive 2. So this y equals 0 is a good answer, and this y equals negative 6/5 is a good answer. And we move on to our final problem. Yay! Final problem. So the final problem, we go ahead once again, rewrite this to have some space to operate. This is going to be x plus 1 over 2x plus 5. Now, like I said, I like to do this because it's so easy. It's so easy to lose that negative. So I like to do that. And usually that's helpful, so we're going to do it. Now I got to, other than trying to zoom out. So now here I am, I'm going to say plus, and I'm going to give it more space than that, plus, I got a negative 2 over x minus 6 equals negative 6 over 2x squared minus 7x minus 30. Okay, so of course this is factored. This is factored, and I had a student I remember in a class that said, "Well, you know, I think they're probably going to factor these two things." This guy, and I hate to tell you because that's kind of cheating, but it's kind of true though, because you know they usually don't want to make it so hard that you have 4 different unique factors. But let's go ahead and factor this. It needs to be factored. You can't just guess. But, you know, he was right, though. It does kind of become that often. So remember, this is not an easy factoring problem. Darn it, I wish it was. But it's not, because that is not a 1. So we must multiply those two numbers to try to figure out what two numbers will multiply to negative 60 and will add to negative 7. Well, darn it, I don't know. Well, we have to have a negative times a positive to get a negative. Okay, and so what multiplies to 60? Well, and adds to, or actually the signs are different, so they're going to have a difference of subtract to get a 7. Certainly not 1 times 60, and not 1 times 30. Why am I putting it down? I don't know. And not 3 times 20. I'm being systematic, though. 4 times 15 is the next one? That's not going to make a 7. And then we have 5 times 12. Wait a minute. How about a negative 12? So negative 12 times 5 is negative 60, and negative 12 plus 5 gives me a negative 7. So remember how that worked? We've been doing so many easy factor problems. Do we remember how to do the harder ones? Well, I think I'm going to do it over here for space purposes. So remember what we had. We had 2x squared minus 7x minus 30. And we've got to replace the negative 7x with these two blue terms. So we got 2x squared. We replace the negative 7 with negative 12x plus 5x minus 30. And then we just factor by grouping. We're going to factor out a 2x, leaving us with, in another color, leaving us with x minus 6. Now I better get x minus 6, so I'm going to assume that, but don't totally assume it because you know what happens when you do that. So see, what times x gives me a 5x? So let's see if 5 can be factored out. 5 times x is 5x, 5 times negative 6 is negative 30, and yay, that worked out. So this particular problem right here will factor down to x minus 6 times 2x plus 5. Huh, was that guy right? Let's see, 2x plus 5, 2x plus 5, x minus 6. Yeah, it was the same. Okay. Anyhow, we need to find the LCD. Now, the LCD is going to be quantity 2x plus 5 times the quantity x minus 6. So we multiply each term by that. And also, yeah, I think we better do this before we forget. Remember the restrictions. 2x plus 5 better not ever equal 0, because if this equals 0, 0 times, I don't care what that is, the whole denominator is 0. So you subtract 5, so 2x better not equal that. Divide by 2, x better not equal negative 5 halves. There's one restriction. And what x better not equal what? X better not equal 6. X better not equal 6. Got two restrictions there, okay? Let's go ahead and multiply by the LCD so we can clean this fractiony thing up. And we're going to multiply by x, the LCD, x minus 6 times 2x plus 5. And also 2x plus, 2x plus 5 times the quantity x minus 6. and 2x plus 5 times the quantity x minus 6. Let's reduce. Reducing common fractions, or factors rather, 2x plus 5 and 2x plus 5, and then we just multiply. So this gives us x squared. The middle term is going to be negative 6 and 1 is negative 5x in the middle, and 1 times negative 6 is negative 6. Let's do the next one, since that first one was so awesome. X minus 6, x minus 6, distribute the negative 2. You see why it was nice to write that negative 2 up top? Because we might forget that negative. Just call it 2, right? So negative 2 times 2x is negative 4x, and negative 2 times 5 is minus 10. And by the way, that's really where people forget the negative, is on the second term. If they get the first, they often miss the second. Now this whole thing equals, I'm running out of space over there. I should have dropped it down a little bit. Oh, wait, I can, can't I? I could use my special little tool that helps me drop it down. I'm feeling so tech savvy these days and good about myself. It's really a great esteem builder. Anyways, let's go ahead and self-esteem, I should say. X minus 6 reduces 2x plus 5. 2x plus 5. Wow, it almost all reduced. We're left with a negative 6. So now we are going to combine like terms on this left side. I've got this x squared. Negative 5x and a negative 4x is going to make negative 9x. And of course, a negative 6 and a negative 10 is negative 16. It's a quadratic, so we've got to set it equal to 0. How about if we add 6 to both sides, so it's equal to 0. And the left side is now going to be x squared minus 9x minus 10. And yay, it is an easy factoring problem with that little 1 right there. So we say, ask the question, the wonderful question. What two numbers multiply to negative 10 and add to negative 9? How about x minus 10 times x plus 1? Let's see. Negative 10 times negative 10 times 1 is negative 10. And negative 10 plus 1 is negative 9. Yes, that worked. So we go in for the final answer. We set that equal to 0, so x equals 10. We set that factor equal to 0, so x equals negative 1. We go to our restrictions list. Don't forget that. And we write it down. Well, they're pretty close. I'll write it down. X cannot equal negative 5 halves. Well, I didn't get that. X cannot equal 6. Well, I didn't get that. Hey, I got 2 answers this time. 2 good answers. X equals 10 or x equals negative 1. And that is the, last problem of this homework section. And this is 5.4. I hope this helped. I hope you have a great day and have a good one. Bye.